Hi everyone, welcome to Educon Community Java interview series. So earlier we have made two videos on this Java interview series. So now this is the part number three. Okay. So let's discuss some more questions. Okay. So the first of all, that is very much important questions for any Java interview. Okay. Like what is the internal work of the hash map and what changes were introduced in Java 8. So if you have seen my earlier videos, okay, in my YouTube channel, this Educan community, I have discussed two to three times these questions. Okay, here I will discuss point wise, like how you will give the answer in in front of interviewer. But in detail, I have discussed already. Okay, that is almost 10 to 15 minutes of video. Okay, so, like from these questions, what interviewer actually wants to know? So, do you understand the hashing, then collision resolution, and performance characteristics? Okay. So, internally, a hash map works on the principle of hashing basically. So, it uses an array of nodes or buckets to store the key value pairs. Then you need to discuss about the put method and the get method. Okay, so when you call the put method, it basically calculates the hash code of the key and applies a bitwise AND operation to find the bucket index and store the node. So it basically the hashing. Okay, like when it will calculate the hash code and it will apply a bitwise AND operation, okay, to find the bucket index and stores the node. That is basically the hashing, like hashing after that storing. And now the hashing process completed. Now you from the hashing you got the bucket index. Now two keys has to the same index. It can happen, right? It can be happen. So if two keys has to the uh, same index, then collision basically occurs. So when collision occurred, so before Java 8, what behavior was there, and after Java 8, what behavior is happening? So before Java 8, collisions were handled strictly using the linked list at the bucket. However, to improve this worst case performance from this ON, like big of n to big of log n, then Java 8 introduced a change. What change? If the number of nodes in the single bucket reaches a certain threshold, okay, this threshold value, like usually 8. So when it reaches the certain threshold value, then the linked list internally will transfer into balance tree. What balance tree? No, red black tree. So when the number of nodes drops below 6 again, then again it will convert back to the linked list. Okay, so what are the key points here? I'm removing these underlines. Then what are the key points here? So the first key point is hashing. You need to discuss. Then you need to discuss when this put method called, how the hashing is being done, like the how the hashing process is happening. Like it applies this bitwise AND operation to find the bucket index. So hashing, then put method, then bucket index. Now you need to give the answer with the collision. Okay, that has been done. Then collision. So when two keys has to the same index, then collision occurred. So collision occurred. After that, you need to discuss about the collision resolution. So for that collision resolutions, what was before Java 8 and what is introduced during the Java 8. Then the performance characteristics, like why it happened, like why some change have introduced during Java 8, like to improve the worst case performance from big O of n to big O of log n. Okay. Now you need to discuss like what change happened. Like earlier linked list was being used and now linked list to red black tree, like the balanced tree conversion, and vice versa. That is happening. Okay, thorough detailing is required. Now, going to the next question, how does concurrent hash map achieve thread safety, and how is it different in Java 8 compared to Java 7? So, what interview wants to know? Like the deep understanding of the concurrent collections. So, concurrent hash map provides thread safety without locking the entire map, unlike hash table. What happens in the hash table? Hash table basically totally lock the map, but concurrent hash map will not lock the whole map. In Java 7, it used segment locking or lock stripping, dividing the map into 16 segments, meaning only 16 threads could write concurrently. But in Java 8, segments were removed. Instead, it uses a combination of compare and swap, CAS, compare and swap operations, and synchronized blocks. So, what introduced in Java 8? Segments got removed, and it uses the combinations of compare and swap operations and synchronized blocks. So now no segments are there, but synchronized blocks are there at the node level. What is the node level? Now the head of the bucket. Okay. So this means locks are only applied to the specific bucket being updated, massively increasing the concurrency. Read operations do not require any locks. So earlier what happens, like in Java 7, it used the segment locking. So lock happened and there the map was being divided into the 16 segments. So only 16 threads could write the concurrently. But in Java 8, segments were removed, and what it is using? It is using the combination of compare and swap operations like the CAS operations, CAS, okay, and synchronized blocks at the node level. So this means the locks are only applied to the specific bucket being updated and massively like increasing its concurrency. So this happens during the write operations, but during the read operations, there are no locks. Okay, so in this way, it achieves the thread safety. And okay, now what is difference between the executor service and completable future? So during the async programming, you basically use the executor services and the completable future, right? So here, what interview wants to know? Modern multi-threading concepts, clarity. So executor service introduced in Java 5 and is great for managing a thread pool, okay, and executing the callable or runnable tasks. However, it is fundamentally blocking when you want to get the result using future.get, right? So you also cannot easily chain multiple tasks together. So when you will use the executor service, it basically blocking your like the result when you want to get something from the future, and it also cannot easily chain multiple tasks together, right? But in case of completable future, which introduced in the Java 8, implements the completion stage. It allows for truly asynchronous non-blocking programming, and you can chain multiple asynchronous operations using methods like then apply, then accept, then combine. Okay, and it provides excellent built-in exception handling via exceptionally or handle method, making it much superior for complex asynchronous pipelines. Okay, so that's why currently from Java 8 for async programming, we always use the completable future instead of the executor service. Earlier, if you would see the earlier programmings from like if you can see from the GitHub, okay, many big projects are there. So there you can see like earlier executor services are being used, but currently completable future. If you will search like that, the completable future implementation in the async programming, you can see. So in this future.get, like we didn't have any proper methods like through that multiple tasks can be done together. So multiple like chaining was not happening. Okay, but in case of the completable future, we have many methods like then apply, then accept, then combine, like that. So it provides excellent built-in exception handling via exceptionally also. And via this then apply, then accept, and then combine, we can chain multiple tasks. Okay. Now, can you explain the garbage collection works? How the garbage collection works and how, like what the differences between the G1GC and JGC? So from this, what interview wants to know? JVM tuning and memory management. So garbage collection is the JVM's process of reclaiming its memory by destroying unreachable objects. Like whatever objects are not being used, it's basically deleting those things from the memory and it gets the memory. That's the garbage collections, you know. The G1GC means the garbage first garbage collector. So it partitions the heap into equal sized regions. It works concurrently to track which region contains the most garbage and collects those first. And it's the default in Java 9 Plus and aims for predictable pause time. And in Java 9 Plus, like this garbage first garbage collector introduced. Like it introduced earlier, but by default in Java 9 Plus, it's happening. And J garbage collector that is introduced in later Java versions like Java 15 plus production ready. So that is basically scalable low latency garbage collector. So it performs all expensive work concurrently without stopping the execution of the application threads. JGC promises pause times of less than a millisecond, even a multi-terabyte heaps, making it ideal for ultra responsive applications. Okay. So in G1GC, there was some predictable pause time. Okay. And in that point of time, it actually collected the garbages. But in case of JGC, there is like less than milliseconds pause times. So even on multi terabyte heaps also, it making it ideal for ultra responsive applications. Now, what are the Java records and why would you use them over Lombok's data? So what interview wants to know? Like knowledge of the recent Java features, like Java 14 or 16. So record is special kind of a class introduced to reduce the boilerplate code for immutable, remember this term for record, immutable data carriers. So when you declare a record, the compiler automatically generates the constructors, getters, equals, hash codes to string methods. The main difference from Lombok's data, like at the rate data, is that records are deeply baked into the Java language and strictly immutable. The fields are final. Lombok's at the rate data creates the mutable objects by generating setters. But in the records, there are no setters. We cannot modify those values. Okay. So those are the immutable objects. If you need a pure immutable data transfer object, records are the native, safe, and linear choice. Right? Now question 6. How does Spring's transactional annotation works internally and what happens if you call a transactional annotation method from within the same class? So from this interview wants to know about your Spring aspect oriented programming concepts. So Spring manages the transactional annotations using the aspect of oriented programming proxies. Okay, how Spring manages transactional using the AOP proxies. When you inject a bin with this annotation, Spring basically wraps it in a proxy class. Okay. Then when a method is called from the outside, the proxy intercepts the call, begins the transaction, calls the actual methods, and then commits or rollback based on the exceptions. If any exception will occur, then it will be rollback. If it will be clear, like no exceptions, then it will be committed. However, if you call a transactional annotation method from another method within the same class, the transaction will not be triggered. This is a classic self-invocation problem. The call goes directly to the method via the this reference, bypassing the Spring proxy entirely. Okay, so see, this is the classic self-invocation problem. The call goes directly to the method via the this reference, right? So Spring basically manages the transactional annotations using AOP proxies. When you inject a bin with this annotation, Spring basically wraps it in a proxy class. When a method is called from the outside, the proxy, what does? The proxy intercepts the call, then it begins the transaction, calls the actual method, and then commits a rollback based on the exceptions. Now, what are the virtual threads and how do they differ from the platform threads? So, for like interview wants to know the awareness of the Java 21's biggest feature, Project Loom, the virtual threads. So, traditionally, Java's platform threads map 1:1 to OS threads, which are heavy, expensive to create, and limit scalability. Virtual threads introduced in Java 21 are lightweight threads managed in parallel by JVM, not the OS, like in the platform threads, OS totally managed. But when virtual threads, then JVM totally managed. So you can create millions of them without crashing the system. When a virtual thread hits a blocking operation like a database call, the JVM unmounts it from the underlying OS carrier thread and assigns another virtual thread to run. This solves the thread per request bottleneck in high throughput applications without requiring complex reactive programming. So basically, why virtual thread introduced? Earlier platform threads were heavy, expensive to create, and scalability was not so high. But in case of the virtual threads, it can be managed totally via the Java virtual machines, not through the OS. And we can create multiples, like millions of threads. Whenever we want, we can use those. And when some blocking operations, like the database call type of operations are happening, JVM basically unmounts it from the underlying OS carrier thread and assigns another virtual thread to run. Okay, so that's why threads per request this problem solved. Okay, and we also no need to do any complex reactive programming. What's the difference between the map and flat map in Java streaming? So mastery of stream API actually interviewer wants to know. So both are basically the intermediate operations, but they serve different purposes. What is that? So map is used for the data transformation. It takes an object and applies a function to return a single new object, and it represents a one-to-one mapping. But in case of flat map, on the other hand, it's used for transformation. Here also data transformation, but here like not only the transformation, also the flattening. So if your mapping function returns an array, a list or another stream, flat map basically extract those elements from those inner structures and flattens them into single continuous stream. So it represents one to many mapping. Now, how do you completely prevent a singleton class from being instantiated from more than once? So basically, interview wants to know advanced design patterns and use cases. So a basic singleton uses a private constructor and a static instance variable. However, it can be broken using reflection, serialization, and cloning. Okay. So earlier, suppose when you have learned the singleton, so you have learned that the private constructor is there, right? A basic singleton uses private constructor and static instance variables, but it can be broken using a reflection, serialization, and cloning. So to make it completely safe, so prevent reflection by throwing an exception inside the private constructor if an instance already exists. Prevent serialization issues by implementing the read resolve method to return the existing instance, and prevent the cloning by overriding the clone method and throwing clone not supported exceptions. Alternatively, the most foolproof way recommended by Joshua Bloch is to use a enum to create the singleton. As Java guarantees, enums are instantiated only once. Okay, why? So Java guarantees enums are instantiated only once and are inherently safe from the serialization and reflection attacks. So, so to prevent the reflection, what we can do? We can throw an exception inside the private constructor itself. We can prevent the serialization issues by implementing the read resolve method to return the existing instance, and we can prevent the cloning by using the by overriding the clone method and throwing the clone not supported exceptions. And alternatively, we can do one thing like the Joshua Bluch told, like to use an enum to create the singleton instance. Why he told, as Java guarantees that enums are instantiated only once and inherently safe from serializations and reflection attacks. Now, the last question for this lecture: how do you resolve the circular dependency in Spring Boot? So, practical Spring Boot architecture troubleshooting you can do or not, that actually interview wants to. So, a circular dependency happens when, suppose, bean A depends on bean B, and bean B also depends on bean A. So, that basically context, like causing the context initialization to fail. So, to resolve this problem, the best approach is to redesign your code, or you can extract the share functionality into the third one. Like you can introduce one bin C. Okay, then that can be cut. That can be cut. You can depend on this bin C. Bin B also can be depend on bin C. We can do that. And if the refactoring is in like immediately not possible, then you can use one annotations. Which annotations? Lazy annotations on one of the dependencies. So this tells what? Like Spring to inject a proxy instead of the actual bin during initialization, like delaying the creations. Like suppose if bin A, now it depends on bin B, and bin B also depends on bin A. But we are not eagerly instantiating. Like we are not initializing those eagerly. Suppose we will add this lazy here. So at the same point of time, it will not initialize. So suppose at the initial point, suppose bin B initialized and it took all the dependencies from the bin A, and when it's done, like after that, whenever it will require like for the bin A, then the bin A will come into the picture, and then it takes the dependency from the bin B. Okay, so through the lazy annotations, we can do that. So we can delaying the creations of the bin until it's actually needed at the runtime. So using setter injections instead of constructor injection also works, but lazy is the common workaround. So we have discussed this 10 important, very important questions. Okay. So do like, share, subscribe uh, for more such discussions. Okay. We will discuss more and more. Okay. That's all. Thank you, everyone.